Hello and welcome to today's VMware webcast. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located to the left of the slides window. You can also use the question and answer box to get technical assistance if you should need it. The tabs located in the question and answer box are where you can find additional information about today's presentation. Today's presentation features streaming audio only, so there's no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter and today's content. You can also fine-tune the audio by using the volume controls inside the media window. This presentation console allows you to interact and customize the layout to fit your viewing needs. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of your screen. Now, I'd like to turn things over to today's presenter to get things started.
Hello, and thank you for taking time out of your busy day to join this webinar. My name is Ron Fuller. I'm a Senior Technical Product Manager at VMware. And today we're going to talk about some emerging networking and security capabilities for VMware Cloud on AWS. This is going to be a demo-heavy session, so hopefully you're in for a lot of fun and a lot of great information to share. If we take a look at our agenda, we're going to start with level setting on what the NSX Advanced Firewall add-on is. And then we'll go through some of the key major features of this solution, right? So we'll talk about the Advanced Firewall's IDS, IPS, intrusion detection and prevention services, and then we'll do a demonstration. Then we'll shift our focus into the Advanced Firewall FQDN filtering, the fully qualified domain name filtering, and then we'll do a demonstration of that too. So hopefully you're seeing a pattern here, right? And then we're going to go into the Advanced Firewall and talk about it from a Layer 7 firewalling perspective. We'll do a demonstration, we'll wrap it up with a summary, and then we'll do a live Q&A at the end, so stick around. So when we talk about the NSX Advanced Firewall, really we start with kind of level setting with what is part of VMware Cloud on AWS, software-defined data center out of the box. We've got intrinsic security built into the environment across the board that starts off with the edge gateway firewall at the very perimeter that you need to configure to allow traffic in and out of the data center. And then that also builds the foundation for the compute gateway firewalls, the CGW firewall, as well as the management gateway firewall. Inside of the workload space, there at the top in the compute gateway section, we've got the distributed firewall, which is designed to be an east-west firewall to provide that micro-segmentation capability that's been so popular in the on-premises VMware NSX deployment space that's available out of the box within VMware Cloud on AWS. What we're doing with the NSX Advanced Firewall, though, is bringing some additional functionality into the environment. We're bringing a Layer 7 distributed firewalling that leverages application IDs, as well as providing the support for distributed, fully qualified domain name filtering. We also have Identity Firewall for primarily a virtual desktop or a VDI type of use case. And then also the distributed IDS IPS that allows us to be able to really layer in some additional security to provide that granularity that customers are looking for to be able to protect their workloads as they move them into the cloud. So when we look at it from a demo topology, we've got a very simple environment set up to make these demonstrations a reality. We have a single software-defined data center, a single VMware Cloud on AWS environment that has all of those firewalls that we just mentioned, the CGW, MGW, the Edge Firewall, and the Distributed Firewall. And we've got a single segment with a couple of virtual machines deployed on them. We're going to focus on the DVWA, which is our vulnerable web application that we're going to utilize as our attack victim in this scenario. And our attacker, for the most part, is going to be this desktop one. Now, I think it's important to note because it really illustrates the power of microsegmentation and the east-west functionality that we're bringing to the table by having both of these machines live on the same IP subnet, 192.168.1.0. I think it's a /24, right? So .2 and .3. So these are on the same subnet. We're not hairpinning traffic through an appliance or anything to make this a reality. We're able to leverage these functionalities, these security control mechanisms inherently there in the environment. So let's take a look at the IDS IPS and see what it brings to the table. So the NSX distributed IDS IPS functionality builds upon the foundation that we already have with the NSX virtual distributed switch, as well as the distributed firewall, right? The distributed firewall has been around for 7+ years and has been very widely deployed and successful and proven to be a very scalable solution. And the way that it does that is by leveraging the power of that distribution. It's in the name, but it's something that a lot of people will commonly overlook. And I think it's so important to point out that we are leveraging the compute resources on each individual host in the software-defined data center to provide firewall functionality at the per VNIC level for each of the guest workloads in the environment. And that gives you this really, really granular capability. So we have that functionality that's already in there. We build on top of that to do a distributed IDS IPS functionality. So we're able to provide some of that similar scale and some of that similar functionality at a higher level in the stack to provide advanced threat protection in the infrastructure. And this certainly lends itself to provide the ability to be able to minimize blind spots in the environment. We leverage a curated signature distribution, which means that you have fewer false positives, which is key. Anybody who's a security practitioner that's kind of been there, done that, realizes that false positives just waste everybody's time, right? Time and resources. You get the team spun up, there's a war room, and you go through the troubleshooting process to find out that, oh, this is normal behavior and we have a false positive. So we at VMware take that workload or that work effort away and minimize that so that you can focus on the things that are important for you and your business, right? And then also being able to have, because it's part of the distributed functionality of the DFW, the distributed firewall, we're able to extend that functionality and have it follow the workload wherever it goes across the environment through vMotion, right? So it becomes part of the state of the virtual machine. So it's a very powerful solution, and it really helps customers build that defense in depth mindset where I have my traditional perimeter firewalls and IDS IPS appliances and things. But once I get inside the data center, I'm able to provide that similar functionality at a more focused and targeted level to, again, provide that defense in depth and meet my compliance goals or security requirements. So that's enough slideware. We're not going to bore you with a lot of slideware today, right? We're going to get straight into the demo. So let's jump in and take a look at the demonstration and go into the detail here. And here we are inside of the demonstration environment. We are already logged into the particular SCDC that we're going to utilize. And as we saw in the previous demonstration for Layer 7 firewalling, we already have the add-on enabled. So we're going to go to the new tab over here on the left-hand side, the distributed IDS IPS, which will bring us to this page. And we're going to start kind of moving from right to left with regards to configuration of a new environment. So our first priority will be to define our signature policy, whether we want to do automatic updates, which is recommended. So we'll go ahead and click that. And then also we can see things like the signature management with regards to what the signature set comprises of, the 15,532 signatures, as well as being able to view and change versions. And this will obviously be modified as time goes on, as your system automatically downloads these new signatures and applies them. But it's really interesting because you can go into the change details and see new signatures that have been added, anything that's been disabled, or anything that's been updated, right? So we try to provide that visibility for our customers so they have an idea of what's going on with each signature update. And then you certainly can always pick whichever signature set you're the most comfortable with or meet your requirements. But in general, I think most security practitioners would agree that they want to run the most current ones to be able to minimize their potential exposure to new vulnerabilities. Additionally, for those of our customers who might have an air-gapped cloud infrastructure where there's different security mechanisms and controls with regards to who can access the management resources, there's an opportunity to upload IDS signatures as well. So those can be downloaded from the NSX Threat Intelligence Cloud service and then gone through whatever the process is to get them into maybe a Bastion host or something else that would have access to the management infrastructure, and then being able to turn around and upload them into the environment. So from a signature standpoint, we've defined our policy. We want to have it automatically update and use the new versions. And we're going to go ahead and we've already enabled it on this particular cluster. If you had multiple clusters, they would show up here. and you could enable them or disable them as appropriate. Now, it is important to note from a licensing perspective that we license all hosts in the software-defined data center, but we do give you this granularity as to where you want the IDS enforcement points to be. So in this case, we've only got one cluster. We're going to enable it on cluster 1. Our next task will be to define a profile. Now, there is a system default profile, but the profiles really give us an opportunity to define what type of signatures we want to be looking for. So for our example, we'll do a critical and high signature profile, and we only want to look for critical and high signatures. So you can see I'm not terribly creative with my naming, but I think it's important to have that simple naming infrastructure so that when somebody looks at it at 3 o'clock in the morning, they understand what you're doing. So we're going to deselect medium and low. And then this is also a very powerful attribute that you can configure on the profiles, being able to define the attack types and the attack targets, as well as the CVSS scores and the products affected. So maybe you have an environment where we'll just pick on, say, Adobe as an example, right? So if I only want to look for Adobe signatures, I can type in Adobe and say, hey, I only want to look for Acrobat exploits as an example, right? And have that very kind of laser granular focus. Maybe it's SQL in your infrastructure or something else, right? But you get the idea that you can be very granular in how you apply that. Additionally, I can do the same thing with the CVSS. I can say, you know what, I only want to monitor, or I'm only required to monitor, critical CVSS vulnerabilities. And that's fine too, right? So I can apply that and have that be an additional filter. So I can be that very laser focused with how I want to do this. And then I can also do the same thing with attack type and attack target. There's a couple of benefits to doing this. One of them is I'm reducing the amount of work that my system has to do to inspect traffic as it goes through the environment, which obviously reduces the overall resource impact of the inspection. But it also gives me that kind of comfort factor that I'm being laser optimized and minimizing my potential for false positives. Additionally, I can also manage the signatures for this particular profile, and we'll touch on that in just a little bit. But know that remember that this is an opportunity to manage the signatures specific to this profile, so I can be, again, very, very granular. So we're going to go ahead and save it. And we've now created the profile critical and high. Now we have the profile, we have kind of established what kind of signatures we want to be on the lookout for. Our next task will be to define a rule. And the rule is exactly similar to what we have in the distributed firewall, where you define a policy and then the appropriate rule that tells us where we want to inspect the traffic. So we're going to create a new policy called secure app and add a rule to it, right? So our rule will be secure app rule. And we're going to define what you would typically do for a normal firewall, right? I want to define my source and destination pairs. I'm going to say my sources are going to be for local prefixes. Local prefixes, if you recall, is a group I create that's based on tags for every segment in my infrastructure. So it becomes really easy to be able to do this, but obviously you can create your own group and be very specific to your particular requirements. And we're going to leave our destinations at on any service because we don't know really where these attack vectors might come from. And here's where we're going to apply our IDS profile that we just created in the previous step. We're going to select the IDS profile. So we'll select critical and high from the list. And again, we made that to be specific to just the critical and high alerts that are in the environment. And then we have a mode, which can either be detect only or detect and prevent. So as its name implies, if it's intrusion detection services, then it's detect only. If I actually want the system to take an action against an event, I would do detect and prevent, right? That would be the intrusion prevention function. Most customers usually start with detect only just because they want to make sure that there's no false positives and that they don't potentially impact their production traffic if it somehow matches a signature, which is fine, right? You can always change this later. And then we also have the traditional DFW logging options where we can say, we want to have a log label, so let's do critical and high, and this just makes it easier to search in our log insight platform, our syslog server, as this log label gets appended to every message. So let's go ahead and publish this rule set. It'll be in process, and now it's successful. So now we have a profile defined, our policy is applied, and here's our events tab. which right now, luckily, our environment hasn't had any intrusions detected in the last 24 hours. That's great. Let's change that, right? So now let's go over to our desktop machine, and we can see 192.168.100.2. So we are on the same subnet as the victim VM that we're going to utilize, which is a security appliance called DVWA. So we're going to go out to DVWA, log in. And this appliance is designed to be used in this kind of environment, right? To help customers test their infrastructure. So we're going to do a SQL injection attack. So we've already got a SQL database that's configured on here. We can do a quick query for user IDs, and we can see that it returns different results, right? So it is a real SQL database behind the scenes that now we're going to try to exploit with a SQL union attack. So we'll go ahead and submit that. Now the behavior of this application is that it just returns back to the main screen, which is fine. Let's go back to our events tab though and see if we see anything pop up. And we already do, right? So we see we've got just right now, based on the timestamps, October 1st at 11:25 a.m. Eastern, we've got a SQL injection union attempt, right? So we're already triggering these types of activities in our environment. And we can expand this and take a look at the detail on it, where we can see details on the client VM and the attacker, right? So in this case, 100.2 attacking 100.5, the amount of traffic and the traffic flow direction. And then we can see from our color coding that it's in detect only mode, which is the little purple icon here, right? So that's that gives us that information. And additionally, we can see the type of attack, right? Established to server, web application attack, and the signature ID. Now, this signature ID will come in play in here in just a little bit, because we want to modify the default behavior. So we're going to go ahead and cut and paste this, and we're going to go back to our profile. And as I mentioned earlier, right, we had that opportunity to change actions for this particular profile. Certainly, this could be done globally. My preference would be to do it on a per profile basis, so that you are, again, that kind of laser focus as to what's going on. But there's all the profiles. We're going to search for the signature ID and let it go. And here's the default behavior, which for this type of attack is an alert. Well, we want it to be a bit more aggressive. So we're going to change that to drop. So we're going to apply that change. And now we can see in here that we have made a modification to the default signature set for this particular profile for one entry, right? So we're going to go ahead and save that change, publish it, go and process. Okay, so that has succeeded. If we go back to our event page, this is where we were, right? So just to kind of refresh everybody's memory, this is purple, right? We've detected the event. Now we want to be a bit more aggressive with this, and we're going to tell it to drop. So we're also going to change it from detect only to detect and prevent. Publish that change, and then we will rerun our attack vector. Okay, so we got a success there. That's exactly what we want to see. Okay, so let's go back to our desktop, and we can verify that the database is still working. This shouldn't be surprising. We haven't changed anything that would change this behavior, but what we have done is change behavior that would affect this. So now we launched the SQL union attempt, and if you recall, it returned back to this page pretty quickly, right? It just came back to where we were, and that's the normal behavior. What we've done now is, because we're taking a more active approach, we are stopping that attack from happening. So now if we go to our events, we can see it over here, 11:28, so that's the current activity. And what we will notice is that now we have not only the detected events, but we have a prevented event, right? So now we've gone in and actively squashed this event from happening, right? And that was done on a per signature basis, right? So you have the opportunity to do that and be, again, very granular in your security posture. So one of the things that a lot of customers will ask is, well, hey, so how do I know that actually happened in my environment? For our VMware Cloud and AWS customers, we have a Log Insight Cloud as an offering, and we've got a dashboard specific to IDS IPS that we can scroll down to, and we've got two of them, right? So we have the overview one, which will show our policy events, right? This is where we created the policy and then modified it. So you have a quick look at the change parameters for that particular environment, and then we can also go to the traffic one, which is probably the more interesting one in this scenario, because I want to see what's happening, right? So already we see top sources, 100.2. Hey, that's that desktop that we just launched that attack on. 100.5 is our target. And these are the different signatures and attacks that we've seen in the last 5 minutes, right? So there's our polling interval. And we can see that additional detail here. We can also take a look at the additional detail, what created this alert, or this event. Let's view log query, and we can get those details shown to us. So we can see here, I'm going to shift this up just a little bit to try to get it on screen a little bit better. There we go. We'll just roll down, and we can see the attack vector, right? So we can see it's a SQL injection and the different attributes that trigger this, and the source and destination IP, the signature that was triggered. All of those details that we're looking for, right? So we can have that additional kind of forensic data on this. Now, additionally, for those of you who probably don't sit around and watch your syslog server all day, every day, you have some automation around it probably. We can create an alert on this, right? So let's go to alert definitions. I've already created this alert. I creatively named IDS Severity 1 Alert. And what I've done is I've told it to match a regular expression, right? So now we can go in here and take a look at the logs. In this case, it's going to email me. So I got my email address in there. We can also put a recommendation, call the SOC, strange things are afoot, right? If you're a Bill and Ted fan, bit of a nod or tip of the hat to them with strange things are afoot at the Circle K, but we can call the SOC, and this will shoot an email off to my email address, right? This could be whatever alerting system you want it to use. I'm using my email to do that. So based on the severity 1 attribute that we saw over here in the traffic dashboard for this particular event, and we can see where that alert was generated, right? So we can do the view log query again, and we can see the severity for that we were matching, which is this regular expression here, right? The quote severity end quote :1, and being able to match off of that. So that shows you kind of a quick example of how to do some alerting inside of VMware Cloud and AWS in Log Insight. And also, hopefully that was a helpful demonstration on how we can utilize IDS IPS functionality in the NSX Advanced Firewall add-on to add additional protections and depth to your security across the environment. Thanks so much and have a great day. Excellent. So hopefully that was a helpful demonstration on the power that we can utilize with the distributed IDS IPS functionality, kind of what the alerting looks like, and then also how you can configure your Log Insight Cloud to send you some additional information. So with that, let's shift our focus and talk about the fully qualified domain name filtering capabilities that are available with the NSX Advanced Firewall add-on. So in fully qualified domain name filtering is ultimately being able to define firewall policy based off of DNS queries and responses, and more importantly, the response to the query, right? So understanding, getting the IP address and using that to build the firewall policy. And that becomes very important when we start talking about these large software as a service solutions that are out there that might comprise literally thousands of IP addresses, and being able to not have to worry about managing and maintaining that ever-changing list, but rather be able to get a real-time snapshot of what the DNS query was and the response to it, build firewall policy based off of that. And then having that be part of that distributed firewall enforcement so that it follows the workload around wherever it goes. So this ends up being a really, really good capability to take advantage of. Now, the underlying technique to achieve this is a technology called DNS snooping. And when we look at what DNS snooping is, it's as its name kind of implies, sitting there and listening for the DNS queries to go out over TCP or UDP port 53, the traditional ports and protocols for DNS, and looking at the responses and building that response and saying, somebody was asking for, in this example, www.site.com, and the response back was 10.1.1.100, and then using that IP address that was in that DNS response to build the firewall. Now, certainly there are some considerations that you want to take into account, and I've listed some of them here, right? Being able to understand that anything that's encrypted isn't really snoopable. That's the whole idea of encryption, right? It's scrambled and protected from that perspective, which also means that things like DNS over HTTP or TLS isn't something that we can snoop on. Or if you're using a quick UDP internet or HTTP3, those aren't snoopable because they're encrypted, right? So you need to have that kind of, old school or traditional, industry standard TCP UDP port 53, and then but using that response to build a firewall policy and have that in place. And then the last point is actually really important when we talk about the rule order. We have to have the snooping policy in place before your policy that's used for FQDN filtering actually gets triggered, right? We need to see what's happening before we can take any active actions or steps against it. So with that in mind, let's get out of the slides and go straight in the demo and take a look at this FQDN filtering capability in action, real-time live. Here we are in our demonstration environment. We're in our software-defined data center, and we're going to go to the distributed firewall tab. Now, this is an additional capability being added to distributed firewall, so we're not going to worry about distributed IDS or anything else right now. So here's our existing configuration. We are using a zero trust policy. As we've illustrated in some of the other demonstrations, we have a default drop rule there at the bottom, which means that we're also having to define all the traffic that we want to be permitted. In this case, DNS is obviously very important for modern applications to be able to get out and about and do things that they need to do, figure out where they need to go. So we've got our default DNS policy in place, and life is good. If we go over here to the desktop PC, we can see we are on 100.2. We'll fire up a browser, and we can go out to VMware.com, and we will see we've got an internet connection and life is good, and we can talk to whatever we need to talk with. So in this particular scenario, let's say we're the security administrator. We want to be able to restrict people from being able to access social media. So we're going to go ahead and add a rule to our infrastructure policy. And the order of operation is going to be important here, right? Because the firewall is processes the rules in order. So we'll create a rule, give it a name, no social for you. Little nod to Seinfeld there. And our source is going to be like what we've picked in the other demonstrations, local prefixes. The local prefixes are a group that I've created based on a tag and defines anybody that's inside the software-defined data center. Our destination will be any, service will be any, and we're going to pick a context profile. Now, here's the default context profiles. There's not one created for social media, right? So it's the pretty commonly used applications. We're going to go ahead and add a new one specifically called social media. And I'm not picking on social media. It's just a very common and kind of easy to illustrate example, right? So if you work for any of these social media companies, don't take it personally. It's just a demonstration. So what we're going to do is give it the FQDN name that we want to look for. So we're going to say, hey, let's not let our users get out to twitter.com. Works better when I spell it correctly. Okay, we're going to add also an additional CNAME. So we've learned this from the School of Hard Knocks. TWIMG.com is part of Twitter's content delivery network. We're also going to say, let's go ahead and block, say, Facebook.com. So all right, so we've added Facebook.com. We're also going to go ahead and add in fbcdn.net. All right, and that's another CNAME that's used by Facebook to do as part of its content delivery network. So we've learned that by trial and error, really, is what it comes down to, of doing a Wireshark capture of packets as they leave the guest, and then take a look at the responses and see what else is part of it. So that might be something you'll have to consider as well. But now we've got our social media context profile defined with 4 attributes. Those are the 4 websites we're going to, or URL FQDNs that we're going to block. We're going to go ahead and apply that. And so now we've got this policy: no social for you, local prefixes, any context profile, social media, and we're going to drop them. Now, as we mentioned, order of operations is important. So we mentioned we need to do DNS snooping. So we have this DNS policy here that right now doesn't have any snooping capabilities. It's just allowing DNS traffic in and out. We're going to go ahead and apply context profile for it that enables DNS snooping. So we're going to be able to learn and cache the responses. So now we've got that in place. And additionally, as I mentioned, order of operations is important. We want the DNS snooping to happen before the blocking to happen, right? So in this case, we've got our policy will be, hey, we're going to let DNS go through. It'll be snooped and cached. We're going to block social media sites, right? Those are set to drop. And then we've got our secure browsing and regular browsing. So legitimate browsing requests can go out and out. And we'll go ahead and publish this out to our environment. And we'll wait for this to come back and return a successful status. All right, so we should be good to go. Additionally, one more thing I wanted to do here, because I think it's always kind of cool to see, is the capability to add a log label. And so for this one, we were going to create an easy log label, social media, that we will be able to search for inside a log inside cloud. So we'll publish that. All right, so while that's publishing, we've got our log inside cloud system here ready to go, and we'll go over to our desktop. So we already established VMware.com works. That's a legitimate domain we want our users to be able to go to. We'll go to Twitter.com. And from a user experience standpoint, it'll sit here and hang, right? The policy is that it's being blocked. We'll also try going to Facebook.com, and we don't have a typo, right? It's just didn't come back. Okay. So we can see we're no longer able to go to Twitter.com, Facebook.com, but we are able to get out to VMware.com. So our FQDN blocking strategy is working properly. Let's take a quick look inside of Log Inside Cloud and see what we see in there. So we'll do a quick search for social media. We should see firewall packet logs from this. We'll narrow it down to the last 5 minutes. And we can see that, analytics.twitter.com, right? So these are some of the examples of those other CNAMEs that we want to be able to match against. So that's why we did the asterisk twitter.com. We'll also see in here, hopefully, we should see some of the other CNAMEs that get resolved, right? So there's Twitter, obviously being very persistent from that standpoint. But you also, when you inspect this, you'll see the other CNAMEs that can be resolved down to. So hopefully that was a helpful demonstration. We showed how we can block particular websites based off of the FQDN and the DNS response and query. And thank you so much for taking the time. Have a great rest of your day. Bye-bye. Great. And so that was obviously the fully qualified domain name filtering demonstration, showing how we can go through and configure those domain names that we want to be allowed either permit list or deny listed in our environment. We chose to do a deny list, but equally you could have the implicit kind of deny mindset and only allow a certain list of FQDNs back in, right? So it's very much a choose your own adventure kind of an environment when you start down this path. So our next and last feature, but certainly not the least, we want to talk about the Layer 7 firewalling capability inside of the NSX Advanced Firewall. And before we start, we really want to talk about what layer 7 firewalling really is. And ultimately, it's the ability to be able to define a firewall based on attributes that are at the OSI system model, kind of up, through 5 and 7. So if you go back to, your intro to networking type of courses or things of that nature, where you had to learn the 7-layer OSI system model and all that kind of stuff, we're talking about the higher end of the spectrum to be able to go in and see what's happening inside of the packet, right? And so to do that, if we look at it from an example standpoint, we've got a 3-tier application deployed here. That's a traditional, DMZ app and database tier type of environment. And in this environment, we've got Nginx, Drupal, and MySQL all running on their traditional kind of native supported ports, right? So nothing terribly shocking or surprising from that standpoint. And we've gone through and we've applied a microsegmentation policy, right? We've defined who can talk to what on the right ports and protocols. And we need to do some additional inspection, though, to be able to say things like, hey, I want to make sure that I'm only allowing TLS 1.2 or 1.3 in, whereas by default, the Nginx environment is supporting 1.0 through 1.2. So I need that layer 7 application identity inspection to go through to be able to say, hey, is this actually TLS 1.0 or is this 1.2 and it's permitted? Right, that's a kind of a good example of this layer 7 firewalling, taking it to that next level to make sure that your applications are secure according to your policy. Additionally, we've got our application inspection to allow HTTP, and we'll see this in the demonstration, how maybe somebody could subvert HTTP and do something that we don't want them to do that's not really an HTTP protocol, right? So, but being able to enforce that. And then also, obviously, for a SQL call, we know what SQL calls look like, and understanding that that's what's happening inside that TCP 3306 session. So when we start talking about how it kind of manifests itself, here's an environment where we've got a client coming in with TLS 1.2 to our Nginx environment. And guess what? They're running TLS 1.2. They're good to go. We're going to let them through. We've done that additional inspection to see not only are they coming in on TCP 443, but they're running TLS 1.2. They meet our requirements. And additionally, then the subsequent calls throughout the rest of the 3-tier application that allow us to check for making sure that HTTP is the protocol that's actually being run inside of the environment, and likewise for MySQL. So we're providing that additional layer of security to our infrastructure. Now, how this can manifest itself from a perspective of maybe somebody doing something we don't want them to do, let's insert our black hat type of person, right? Our bad guy who's going to come in and try to use TCP 443, which from a layer 4 firewall perspective, that's good to go, right? TCP 443, you meet the requirements, you are allowed to go through. But what we see is they're coming in with TLS 1.0, an insecure version of TLS. That doesn't meet our requirements, so we want to make sure that we go through and we actually do that inspection and say, hey, you have TLS 1.0, we're not going to let you in, and in turn, stop the attack before it even happens, right? So this is a good example of how we can provide this capability to that deeper packet inspection. It also kind of comes into play from a perspective of being able to utilize this to provide kind of a virtual patching environment. Maybe I don't have time. This is an important web application that's my business's critical front end. I don't have the time or the skills to be able to maybe patch it to not support TLS 1.0. I can implement this firewall to provide, in essence, a virtual patch for my environment, right? So I'm not a big fan of the network solving application problems, but this is a great example of where we can do just that, simplify everybody's life, secure the infrastructure, and add that additional layer of security, and be good to go. And likewise, if we look at kind of how this can build itself out, we look at it from a standpoint of being able to build those compliance zones and being able to be very, very granular on what ports and protocols I allow. Certainly, reduction of attack surface is a big part of the whole microsegmentation mindset and strategy to begin with. I want to be able to say, these are the only ports and protocols that are allowed in my infrastructure, and not have to worry about all the other myriad of ports that are available inside of a IP network. And then equally, I can also take the approach of kind of security by obscurity, if you will, and run my applications over non-traditional ports. So I can now have that application inspection happen on a non-traditional port, but still be able to do that particular application identity stamp so that we can see what's happening. So I think I just spent more time on slides than we are probably looking for. So let's dig into the demonstration and see how this plays out in real life. Okay, here we are in the VMware Cloud on AWS user interface. And we're in the Networking and Security tab. And we are looking at the distributed firewall because that is where the context profiles that we'll be utilizing to do this deep packet inspection are implemented. So we've got our generic infrastructure rules that allow browsing out from our devices in our software-defined data center to the web, both secure browsing as well as just regular browsing, TCP port 80, and DNS for name resolution. And then we've also got a rule that we've created for peer-to-peer that says, hey, I want to enforce some additional security policy inside of my data center from an east-west perspective, and I only want resources that are local prefixes, talking to local prefixes, utilizing HTTP, right? So I'm trying to minimize that attack vector, that capability for lateral movement inside my data center. So we're permitting that. And then because we are doing microsegmentation, we do have a default drop at the end. So we are enforcing policy from the top-down perspective as traffic passes through these filters. It's inspected, and if it meets the requirements, it passes it goes on. If it doesn't match any of the criteria and it reaches the end, ultimately it's dropped. So in this scenario, we can take a look at the server. It was running OpenSSH as an SSH server, and then we have our desktop PC at 100.2. And so in this scenario, we're going to open up a PuTTY session. We're going to minimize this so it looks a little bit cleaner on the screen, and load our Windows profile. And we can see that we're going to 100.3, so the server that we just showed you, on port 80. Now, this is a non-standard port for SSH. SSH traditionally is TCP port 22, but in this scenario, we're trying to circumvent that microsegmentation policy, right? That says that local prefixes can talk to local prefixes only on port 80. So what we can see is that when we do that, we're able to log in, and we'll use the same credentials that we just entered a moment ago, and voila, we are now in through SSH over port 80. Now, obviously, that's not necessarily a great policy to have from a security perspective. So you, as the security admin or the network administrator, decides, hey, I want to implement a new policy that's going to drop SSH. So we're going to create a policy called drop SSH because we're not terribly creative, or I'm not terribly creative, at least. And we're going to go through the similar steps that we do for defining any firewall policy. We're going to pick our source and destination. This local prefixes group that I'm using is one that I've created that is based on, group membership is based on tags that I apply to any of my segments. And so we're going to say anything from inside this software-defined data center to anything else in the software-defined data center is subject to this particular policy. And we're going to say, from a services standpoint, I don't know what port they're running SSH on, but I don't want it to run at all. So where it gets important for us to be able to say, okay, now I want to make sure that I'm looking for SSH signatures, I go into this table of context profiles. So we have some predefined signatures for various applications that we can select from. You can certainly create your own. And we're going to say that anything that's SSH, regardless of the port number that it's allowed to, or that it's running over, we're going to drop. And because I like to log things, I'm going to go ahead and use this log label functionality so that it makes it easy for me to look at it inside of my syslog server and see that things are happening, that the traffic is being dropped by that particular policy. So we will go ahead and publish this rule. And while it's in progress, it should switch to success here in just a moment. All right, so now if we go back to that same desktop and launch PuTTY again, what do you think will happen? Hey, we got prompted for a password, right? We're still not enforcing our policy the way we wanted to. So let's go back and take a look at why that could be. So when we look at our existing policies, we've got a rule here called browsing that says anything from a local prefix to anything that would include local prefixes or externally running HTTP, TCP port 80, is now permitted, right? So still says unpublished. Oh, we changed this stuff. But anyways, we're able to to see that anything that's HTTP is still permitted. Well, in this case, we want to take that next layer of security and say, let's make sure that only HTTP traffic is actually happening inside of there. So we will go ahead and select the HTTP context profile, apply it, and say that it's allowed. So this will in turn enforce that whatever's happening over TCP port 80 is actually matches HTTP, right? It shows up as an HTTP request as opposed to what we were doing, SSH tunneling inside of HTTP. So now we have that policy in place. We're going to do some deeper packet inspection. Now the expected result will be that our SSH policy will pick this up. And let's take a look and see how that plays out. So we're going to go ahead and load this and try to connect. And we're unable to connect, right? We can restart the session. We'll see that it still continues to fail. And we can also verify this over here in our syslog server, login site cloud. And we're going to just do a quick search for sneaky SSH, and we will look for any matches that were recently dropped, right? So in this case, we can see right here, sneaky SSH was dropped. It matched rule 1026 from our source, our desktop PC 100.2 to 100.3 on port 80. But the key thing here is that we're using the application filter SSH. And we can also see that this is indeed the rule that we wanted it to be, 1026. And we can go back over here and verify that in our policy that it is indeed rule 1026. So now we've seen two different ways to utilize context profiles to actively layer in additional security to our network infrastructure. So hopefully that was a quick demonstration of what we can do inside of VMware Cloud and AWS, and hopefully that was helpful for you. Thank you so much for taking your time, and have a great day. Bye-bye. Cool. So that was the Layer 7 firewalling demonstration, and to me that really kind of helps illustrate the power that we're talking here, because we're not only able to filter based on the application ID for what we don't want people to do, but we're also in turn we're able to enforce what we did want them to do, right, with the HTTP policy. So to me that's a pretty slick setup. So let's kind of wrap things up and talk about what we've been doing, right? So certainly, I think we demonstrated pretty comprehensively the capabilities of three of the key functions of the advanced firewall add-on. Certainly, we've got a lot of great additional resources for you, whether it's the frequently asked questions or the distributed IDS IPS product page. There's also some videos out there on YouTube and some good docs on TechZone, the Config Max. There's a lot of information that's here for you that hopefully will be very helpful as you kind of continue your journey through VMware Cloud and AWS and start to look at maybe how you can deploy this advanced firewall add-on in your particular environment, and again layer in that additional security to your infrastructure. So thanks so much for taking the time. We're going to shift our focus and do some live Q&A. So if there were questions that popped up while you were watching the webinar, maybe this is a great opportunity to throw them out there. And if not, well, thank you so much for taking your time and really appreciate it. Look forward to speaking with you all soon. Fantastic. Well, thank you for taking the time to participate. Certainly, if you have questions, don't hesitate to ask. Looks like we've got one that just popped up. I'll go ahead and respond to it. The question is, what version of SDDC do I need to have to use the advanced firewall add-on? You do need to have the 1.16 release, which was just recently made generally available in your software-defined data center to be able to utilize these advanced features that we just demonstrated. So that should be something that's exciting to look forward to. We've got the ability to be able to deploy new SDDCs using 1.16 today. And then if you have an existing SDDC, then we'll just follow the normal traditional kind of upgrade cycle. So, and then you'll be able to turn on these new features and really crank down the security in your infrastructure. Good question. Any other questions that come to mind for anybody? Okay, here's another one. Can I create my own IDS signatures? So the very common question that we get asked. The quick answer is, as of right now, we don't support the ability to be able to create your own IDS signatures. What we do, we spend a lot of time curating, which is, I don't know, almost an abused buzzword, I think, in our industry. But we do. We spend a lot of time picking and choosing the right signatures to minimize false positives, right? So I think most security practitioners probably are familiar with the process today where when a new vulnerability comes out, the signatures are kind of go through a churn process as more details are learned and more kind of use cases kind of uncovered to refine that signature. We take the approach of, let's make sure that you don't have false positives, so you're not chasing phantoms around your infrastructure, but rather securing it with known good qualified signatures. Now that said, the ability to be able to create custom signatures will be available in the future. So you can ask your VMware account team for additional details. We can't discuss it in an open forum like this at this point in time. Let's see. So then we've got another one. Y'all are lively. Thank you. Is it possible to send logs and alerts on my corporate logging solution? Another really common question, right? A lot of customers will spend a lot of time building infrastructure and alerting and other, kind of metrics around using their maybe a non VMware Cloud and AWS vRealize Log Inside Cloud type of solution. Quick answer is absolutely. By default, every log that's created inside of a software-defined data center, including all of the IDS alerts, the firewall logs, and just even general, logs about hosts and disks and other things that happen inside of a network or inside of a software-defined data center, are sent to Log Inside Cloud. Inside of Log Inside Cloud, you have the ability to be able to configure a log forwarding address, and that can be whatever you want it to be. That can be your on-premises system, or that could be something else. So that kind of takes care of that one. So yeah, very common question. Thank you. Another one just rolled in for download signatures not on VMC and using IDS. Where would you do that? Right now, you don't. We don't offer the ability to be able to support IDS signatures either of your own creation or from a third party. They're all done through that tab that we showed in the demonstration, where you are downloading them from the cloud service that we offer. That will change over time as the ability to be able to bring in or to create your own signatures becomes available. And then also additionally, if I wasn't understanding the question 100%, if your environment doesn't allow you to be able to connect to other cloud services to automatically download those, you can manually download them from just using an API call and then turn around and re-upload them into your environment, right? We've got some government customers that have that kind of security restriction where the ability to be able to connect to an external service is prohibited, and this gives them the ability to be able to get that manually. And then kind of a follow-on question is IDS IPS only available on VMC, or can it be done on a private SDDC VCF? Absolutely, this can be done on a existing private SDDC or VCF, assuming that you have the right versions of NSXT deployed in your infrastructure and the right licensing. So that's the feature that we just demonstrated. All of those features are available in the on-premises flavor, as well as now being inside of VMware Cloud and AWS. Hopefully that was helpful. Good questions, everybody. If you have any more, we can keep on rolling. Okay. I've not seen any other questions kind of roll in, so I think we are good to go. Again, thank you so much for taking time out of your busy days. I know everybody gets probably this online seminar, webinar kind of fatigue, so I appreciate you taking the time out of your day to join this one. Hopefully it was a great use of your time. Please fill out your survey and let me know how I did. If it was good, that's great, and if it wasn't great, let me know that too, and I can work on improving. Right. So again, thank you so much for taking the time, and have a great rest of your day.